Start. So in the last lecture, I think we started the circular motion, right?
Yes, yes, sir.
And we did a few questions of circular motion. Any doubt from circular motion? No doubt. So I'll give you a few questions. Okay, we'll just solve few questions. So imagine we have a rough rod, not a smooth one, and there is a ring. This doesn't work. There is a ring actually, which is just exactly almost of same dimension as that of the rod. So it is barely able to move. Okay. And the coefficient of friction is mu. It is rotated in the horizontal plane, and starts from rest, and the angular acceleration is alpha. The distance of the ring is L from the axis of rotation. Mass of the ring you can take as M, although not required. Find the time since start after which the ring will slip. Okay. So after what time the ring will slip?
Initially, it is at midpoint.
No, L distance away.
Okay, and length of the rod
Doesn't matter.
doesn't matter.
The ring,
Okay, it
ring
will
will slip.
start slipping. Okay,
Yeah, yeah.
not come out of the rod, right?
No, no, no.
Okay, okay.
No, 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 not this, not this. Think more, think more. So if you try to do the ABD, first of all, you can see that this ring will move in which plane? Horizontal plane. So till it is not slipping, what is the motion? The path is circular, right? And if you try to look from the cross-sectional point of view, I'll show you something. This is a ring. And the rod is not touching at the top, it is touching somewhere there. Do you realize this? It is going to touch like this.
Yes, sir.
You know why?
The two
Because
forces, one is
yeah,
mg and one is the acceleration, due to the
Correct.
acceleration of the rod.
correct. So the normal reaction has to do two jobs. One, it will provide the tangential acceleration, and it will balance the gravity as well, right? So if you look from this side, it will look like this. Because the normal must have two components, one nx, which will give you the mat tangential, and one is ny, which is balancing the mg. And therefore the friction force here is like how much? The Fs max is how much? Mu into this n, correct? It is not
Yes.
mg. So basically it is mu into under root of g square plus at square. I think m will come here. I hope this is correct. And for slipping condition, what will happen? Now the friction will act in which direction? The friction will act towards left.
Inwards, yes.
So we know that Fs equals to m omega square L. And we have to, for slipping, the Fs would be equals to Fs max.
Yes.
So we can say this is equals to mu into n equals to m. And now we can attach mu mg, mu m g. And at square is what? Alpha square t L square.
Alpha square L square.
And omega is alpha t. Am I right?
Yes.
So now because we want t, so you can rearrange. Or you can make it power 4. So mu square. P power 4 is so yeah, so you can take the fourth root. You can further simplify in terms of writing, but that's the answer. So please do keep in mind such question will come. You have to be very careful. You have to understand that which force is the responsible for what. Here, friction cannot provide the tangential acceleration. Do you realize this?
Yes.
So I'll go to the quite similar question. Hopefully you will not make a mistake this time. So you all have done this before, just do it once again. So this is a ruler of flat surface, which is again supported at one of its end and about which it can rotate in a horizontal plane with angular acceleration alpha. And now this time what we have is a block. So we have block, doesn't look good, but this is it. And the block is kept on the surface and it is at a distance L. Same question. Find the time after which the block will slip. Tell me. Tell me thanks.
So
Yes.
is it under root mu G minus alpha L upon alpha square L?
It should not be minus, it should be plus only. I mean something plus. So here the question is, who will provide the tangential acceleration?
Friction.
And who will provide the centripetal?
Also friction.
Also friction, so which means friction cannot be acting like this, right?
Yes,
Yeah.
friction will be
Yes, sir.
at an angle, basically.
Correct. So if I look from the top view,
Hmm.
and if I consider the block somewhere, anywhere, then the friction will acting something like this. But here N is mg only, right? So here friction will provide both, which means friction will provide the total acceleration, right?
Yes.
So here Fs is ma. It is neither AC nor AT.
AT.
It is A. So this is equal to A, which is equal to m omega square L. And sorry, what I'm saying.
No.
A, mu n.
Omega.
I mean, like we have to make the maximum case. So for sleeping
Mu
condition,
mg.
mu n, yeah, correct. So for sleeping, you start the Fs equals to Fs max which in turn is, so this is mu mg is m under root of AC square plus AT square.
80 we can write as alpha r and
Yeah, I think
AC.
yeah, minus is coming. Minus. Correct, correct.
Oh.
You should minus, right? Yeah.
Yeah, mu square b square minus alpha square L square upon alpha raised to
Correct,
4L.
correct, correct. So it is omega square L whole square is alpha square. Am I right?
Yes, sir.
Yes, sir.
And now we can take under root.
And oh no, yes, yes, yes. So alpha becomes what? Omega becomes alpha t. Oh, so this is
Alpha L.
Yes.
no, I was right. It is plus
Actually, see, there omega you also need to replace with alpha t, right?
correct, correct. So it is alpha t, which is alpha square t square L
We will
whole
get
square.
a power 4 of t square, then we need to solve for t square and then we need to take the root.
No, just I'm not doing some wrong.
Omega square L alpha, nothing is wrong.
This is correct, no? No. Mu into n equals to m into L.
Ah, that one is mistake. Now you wrote that alpha square t square. That should be alpha square L square.
Ah, okay. Something was wrong.
Ah, now it's easy.
Correct. So now this alpha power 4 t power 4 L square is mu square g square minus alpha square L square, and then t power 4 is okay. So 1 by alpha power 4 L square mu g by alpha L whole square minus 1, and then I can bring alpha square L square common. So t turns out to be 1 by alpha square mu g by alpha L whole square minus 1 power. So these are two critical concepts in horizontal circular motion. I hope this is clear to all of you.
Yes, sir.
Now comes the third case. So in a disk, what we have is a groove, right? So these groove problems are very famous. And you will come across such questions very often in advance. So I will keep the groove spinning with constant angular velocity omega. And to keep it constant, I have to, provide some motorized action. So some motor is connected, and then only we can maintain the omega. Otherwise, omega cannot be maintained. Why? Okay, we come to that. And now we have an object which can slide inside the groove. So this tiny object can slide within the groove freely. So I am not assuming any friction. I may bring friction also into consideration, but as of now, so tiny block can slide within the groove freely is sufficient. Freely means without friction. So I can make this, you can of course bring some more complexity, and omega is constant. So I'll come to the question in which omega is variable. So that will be like a challenging question for JEE. But as of now, let's keep the omega constant for circular motion chapter. If I leave the omega, it will become question of rotational dynamics, where we have to conserve the angular momentum. We'll come to that also, but right now it's this question. And we start with, to make things easier, it is initially kept at a distance of r by 3, and the radius is r, the radius of the disk. Okay. So it is released from rest with respect to disk. Now remember, release from rest means it is not at rest even before, but with respect to disk, it is released. Okay. Or they may give you that, okay, a thread is attached from the axis to the block, and once you burn the thread at t equals to 0, thread is burned. So once you burn this thread, what will happen? The block will start sliding away. Correct? So this is
Yes.
at t equals to 0. So after some time t, after burning is done, it is somewhere here, which we don't know how far it is. So let's call this as R. Now the path of the block is very complex. It is which path? Can you guess?
Spiral.
Spiral. So the question of spiral will be difficult to analyze because it will have the exponential relation, and path is difficult to understand. So the best way to analyze this problem is in the frame of
Block.
disk itself, right?
Okay.
So which frame we will be using, disk or ground?
Disk.
And whenever, yeah, so whenever you use a disk frame, what will happen? The block will experience force towards, I mean, away from center, which is called centrifugal force, m omega square r. Okay, and this will give you a radial acceleration. Let's call AR. AR is the relative acceleration, or you can say radial acceleration. So this is the acceleration with respect to disk, not ground again. So if I want to write the laws of motion, what I have to write? Laws of motion. In the frame of disk, what is the laws of motion? In the frame of disk, what is the laws of motion? Tell me. Hello, hello, hello.
Yes, sir. We can hear you.
Laws of motion, come on. What are you thinking? Laws of motion in disk frame.
In disk frame.
Of course. We are only going to solve in the frame of disk, no?
Yes. So basically, in disk, all forces must be balanced over there, right?
Okay, think about it. Tell me. Take 1 minute of time. Think about it and tell me. The only force I think I can see is m omega square r, which is m and r. That's it.
So the normal from the group will be balanced.
Yeah, the normal is vertical normal is balanced, and the horizontal normal is actually providing the release force. So
So we'll have to consider that too.
of course that is not at all required, no? Because our interest is only knowing the how it is moving along the groove. It doesn't matter how it is moving this way. So this motion is because of Coriolis force, which we write as 2m omega cross v. V radial, VR. VR is called the radial velocity. So it is the
Okay.
radial velocity which will give you this force, and that's why if you apply the cross product omega cross v, omega is this way and v is omega upward, v this way. What is omega cross v? You can see this way.
Yeah.
This is called Coriolis force.
So where does this relation come from?
Pardon?
Where does this expression for the Coriolis force come from?
Application.
Yeah, no, how do we derive this omega cross v?
No, don't know to derive it. So it is of course derived by Feynman, but we don't need to know all this. So you need to know the formula that the Coriolis force is 2m omega cross v, and v is the v radial, but that is not required to us. Okay. So now the only thing is we want to know the velocity of the block as it moves away from the center along the radial direction. Because at any instant, velocity in this direction is how much? At any instant, velocity in the direction of perpendicular to the groove is omega r.
Yeah.
Yes.
That is fixed, no? If you are at r distance away, your velocity in this direction is always omega, no matter what. Isn't it? Hello.
Yes, sir.
So this velocity we need not to worry about. We can calculate without doing any calculation. So this part is clear. How we are writing?
Yes.
I'll just leave this as such. So what is AR here? So it is a function of R. Omega is constant. So AR is function of R. Can we use kinematic equation? Can we use kinematic equation? Yes or no?
No, sir.
No.
So what we can use? Calculus.
dv by dx.
Very good. V dv by dx. So here x is R. So VR dVR equals to omega square R dr. We can integrate now.
Integrate.
So
now.
when
V
R
r
is
square
R
by
by 3, it is 0. So when it is R in general, it is VR. So what is your answer?
V r square by 2 must be equal to omega square 8r square by 9 actually. Oh,
So you
we
can
need
see
to.
VR is how much? Omega under root. Correct?
Yes.
And because V is a function of R, so we can write as a dr by dt. So I hope you know the integration now. By this time, you should be knowing the integration. So when t is 0, it is.
R by 3.
So can you find the R as a function of time t? This is not difficult. Come on. You can do it. So you all know integration?
Yes.
Do it.
Sir,
Hmm.
small r is equal to capital R by 3 into
Just
1
a minute.
upon
Small r equals to capital
capital R by 3 into 1 by under root
1
e
by
raised,
under root. Okay, just 1 by under root
e raised to 2 omega t minus 2 e raised to omega t.
under root.
Ah,
E raised to
2 omega t minus 2 e raised to omega t
2 e raised to
omega t.
like this.
Ah.
No, I don't think so.
There is some
So okay, you don't know integration then. When you guys will learn or master integration? On what day?
Acha, got it.
Sir,
So yeah,
sir, I'm getting r by 6 e to the power omega t plus e to the power minus omega t.
that's correct answer. Very good. This was J advanced, bro. This was J advanced comprehension. So they actually mention all this theory in comprehension itself. That there is a Coriolis force, there is a centrifugal force, and you were supposed to solve, but there was no rule of Coriolis force, of course. Okay. I think this was 2014, 15, something. You can see in the PYQs. It must be there. Is this clear? Josh,
Yes, sir, clear.
you got the answer?
Wait, I think I did a mistake in integration.
Do it again.
I'm getting in terms of ln.
Yeah, so ln you have to convert into exponential.
Okay, just a second.
So you're getting ln of what? Ln of sec theta plus tan theta, right?
Yes,
So I'll tell you something. So you're getting sec theta plus tan theta ln. I will not put the limit equals to omega t.
correct. But now,
Wait. So sec theta plus tan theta is how much?
correct.
So sec theta minus tan theta is how much?
T to the power minus omega t. Yes.
So you can add these two questions, solve sec.
Okay,
solve.
understood.
That is a trick.
Ha.
Okay. And exponential is a confirmation, it's a spiral path, right? The spiral path will have the exponential relation. This is exponential graph. Okay. Anyway, let's go to the next question. So again, it's a very famous question. This is a part of your regular lecture notes. Let's see how much you remember. And this manipulation is also very much essential. You should know how to manipulate things. So we have a circular track with radius r. So a particle is constantly moving on this track. Okay. And at t equals to 0, its speed is v naught. Okay. Question is, if the magnitude of AT is equals to AC at all instant of time, then find the time particle will take to complete one revolution. So question is clear?
Yes, sir.
R is given, V naught is given, you have to find the time after which you complete one revolution.
Sir,
Yeah,
so I'm getting R by V naught 1 minus e to the power minus 2 pi.
that's the right answer.
Okay.
Yeah, per just tell me.
Just
Still, I'm not getting 1 minus actually. Just a second, I'll check again.
Okay, no problem. So these are the manipulation. You know how to manipulate a question in circular motion. Things will be easy.
sir, could you show the answer? I just want to. I'm getting 1 minus e raised to 2 pi v naught.
No, the power cannot be dimension. Power is dimensionless. So you can also see that it's wrong, right?
Yeah.
Anyway, look at this solution. AC equals to 80. That multiple ways in which we can approach the problem. I will show you all the ways in which you can manipulate things. So one is you can express in terms of linear translatory motion. So if you think in terms of translatory motion, then AC we can write as V square by R. And I will write a Vy because I have to write in general, not at the initial position, at any time t. And 80 is called dV by dt.
Yes.
The other approach is you can write omega square R and alpha into R. So basically, the alpha is omega square. This is another approach. Correct?
Yes.
So these are called differential equation. This is also differential because this connect is either d omega by dt or, and again this is you can also write as v d by ds. ds is the arc length. So now it is up to you to choose the method and proceed. So still I'm giving you one more opportunity. Use one of these, proceed and think how to get this. Okay, meanwhile, while you're doing this, so how the same question becomes a tough question of rotational dynamics. So let's go back to the group level. So we have a disk which is freely rotating about this axis. Freely means there is no frictional forces. And at t equals to 0, the velocity of this angular velocity of the disk is omega naught. The radius is r, mass is m. I'll keep it simple. So the groove which I made, so let's say now my block is close to the axis, but not touching the axis. Having the same mass, I'll keep it mass. And this mass m at t equals to 0 starts sliding away from the axis because it is not at the axis. It is slightly off the axis. So the centrifugal force will move it away, right? In the very beginning, the angular velocity is omega naught, but as you will proceed, what will happen? So what do you think? Omega will decrease or increase?
Decrease.
Because if you think how, and if you want to know the reason of decrease, the answer is it is the Coriolis force reaction. So the Coriolis force on the mass is acting this way, which is the normal direction. So the normal reaction on the disk will be acting like this, which will kind of slow down the. So it will create a torque, and the torque will create the alpha, and alpha will reduce the omega. But we are not supposed to solve this way. How we solve? So at any instant time t, if it is somewhere here away, r distance away, then we can use the conservation of angular momentum about axis. Because the only force acting, which is external is the axial forces. So about that axis, there is no torque, isn't it? Hello, hello, hello. So we have gravity on the object which is empty, and gravity of the disk which is empty. But this gravitational force which is external is parallel to the axis, and we know that if a force is parallel to the axis, it will never have the torque about the axis. Do you remember this fact? A parallel force cannot create torque about the axis.
Yes.
So you have to write the conservation of angular momentum about the axis. So in the very beginning, it is disk angular momentum, which is I disk into omega naught plus mass is close to the axis, so it will have zero moment of inertia. mr square is 0, so it is 0. But afterwards, the I disk into omega, and the particle will be also having the velocity in which direction? In this direction. How much is this velocity? Omega of that instant, correct? So mvr is the orbital angular momentum, but it will, you may ask, sir, it will also have VR. This VR cannot have the contribution to the angular momentum about the axis. Why? Because this VR is passing through the axis. Do you realize this? Maybe. So in the MVR formula, we take the perpendicular separation of the velocity vector and the axis. So we always resolve things along the, I mean, in a way it is radial and perpendicular, and then we can get MVR. So your answer will be mr square by 2 into omega naught, mr square by 2 into omega plus m omega r square. Am I right? So
Yes.
just to make it simple, we can keep like this. So, so you can see that omega, if I take common, it is r square by 2 plus r square equals to r square by 2 omega naught. So omega naught upon, if I divide this 1 plus 2 r square by r. So what you can see that omega is a function of small r, right? So as r will increase, omega will decrease, isn't it? Hello, hello, hello.
Yes.
Now, if you want to solve the same question as you did the previous question here, the omega was constant. So your AR was only depending on R, but now it will depend in a
It will
complex way.
depend on both.
Yeah, so it is R, it will depend on R, but in a complex way. So the AR will be how much? Omega square R.
Yes.
But this omega itself is omega naught square by 1 plus 2r square by r square power, oh my god, whole square into r, oh my god. So you can see by doing the small change to the question, it becomes a really challenging problem. And you can see the AR is omega naught square r, what is this? R, yeah, upon 1 plus 2r square by r square whole square. I hope this is clear. Let's to make it easy, let's let omega naught equals to 3 radian. One, you can take one element, 1 radian per second, and capital R equals to 1 meter. So you may get a slightly easier formula, which is 1 plus. Okay. Or better, what I can take? Better I can take as R is root 2. So this will become. We make it a better. So if I take root 2 meter, then AR becomes how much? Oh. R upon 1 plus. And then if you want to write V dV, VR, dVR by dr. And I don't know this is easy or difficult, but maybe JEE can give this question and they will give you the integration also if it is not doable by this means. No, this is easy. This is very easy. It is easier than before, right? Method of substitution.
Yeah.
So
Yes.
R,
Actually, this is one is easy. We can just
Yeah.
replace it by sine or tan. No, sine, not sine, tan.
So you can add 1 plus R square as T. Correct?
And 2R dr dt.
Yeah. So you know this how to solve this. So VI square by 2 equals to, I can take 1 plus R square equals to T. So
Correct.
2R dr is
dr
dt.
dt.
So basically I can add this dt. I'll do this in separate, dt by 2. Correct? 1 plus T is correct. Correct? Tell me guys.
Yes, sir.
It is 1 by 2T. This is correct. 1 by T square is minus 1 by T, right?
Yes.
So it is 1 by 2. So this is the integration. So. So V square 2 turns out to be minus 1 by twice 1 plus R square power. I mean 0 to R. And I can switch the order of integration and convert minus into plus. And it doesn't matter. So upper limit, if you put upper limit, it will give you 1 by 2, and lower will give you. So of course, correct. So it is R square by twice 1 plus R. So VR turns out to be this crazy answer. So they might ask you that when the object will leave the groove, what will be its radial velocity? So at R equals to capital R, which is √2 meter, what is PR? √2 by √3, correct? Hello. Is this clear?
Yes, sir.
And at that instant, what will be the omega? So omega at R equals to capital R is how much? What was the formula? Omega naught, which is 1. I have made already simplified here. It's 1 upon 1 plus R square, right? One by 3. So what is the tangential velocity at that instant? Omega into R. So what is the velocity V at time of leaving the groove? So it is under root of VR square plus VT square. VR was 2 by 3 and VT is 2 by 9. Huh? Am I right, guys? Tell me. So 6 to 8, 8 by 9. So 2 √2 by 3. So imagine that we have taken the question level from something very simple to something very complex. So when you go from the normal chapter to rotational, things will change drastically. If you have any doubt, you can ask. If you have understood, it's good. In fact, as a matter of fact, you can always remember, whenever you have a question of axial motion of disk, cylinder, by default, conserve the angular momentum about that axis. If you don't understand much of physics. If you understand, it's good. You should conserve. Is this clear?
Yes.
Maybe. Not
Yes.
clear. So circular motion and conservation of angular momentum, they are very questionable chemicals, many questions. So you just read the notes, you'll see already. We have solved a lot of questions. But my focus is now on some challenging question of circular motion. So we have seen the horizontal circular motion with alpha present with tensile accession, or we can say with non-uniform circular motion. So I'll go to something called the vertical circular motion. VCA. So now the key concept is, in any vertical circular motion, the key concept is only two concepts: conservation of mechanical energy and Newton's laws of motion. So applying these, you can say circular motion dynamics, CM dynamics. You can say circular motion dynamics, which you know how to write. So to solve any question of vertical circular motion, we have to apply this conservation law. The reason is the object will be moving with the help of a string. And what kind of force string will apply? Now, because of circular motion, the elementary displacement and the tension are mutually perpendicular. So work done by the tension is, and if elementary work is 0, so the net work will be for sure 0. Correct? So if you're doing if you're doing 0 work, so the tension is not doing work, and other force is gravity, which is the conservative force. So either you want to write, you can write the work need theorem, or you can simply write the energy conservation, because it's a conservative force. So I hope you understand this part.
Yes.
So every question we have to solve that way only. So we have a Bob. So you know that to come to this position, how much velocity we need? I want to know that what is the V, so that it can just come here. Exactly horizontal. How much V is required? So because they're asking V, so we can only conserve the energy and we will get the answer. So what is the answer? How much V is required to go there? Tell me quickly.
Sir, under root 2 GL.
Root 2G.
Root 2 GL.
Yes.
Okay, so half mv square goes to mgl. That's it. So potential energy will be mgl if I take this as reference. And in the beginning, it's 0 potential. And the final we have 0 kinetic energy. So then we equals to under root 2j. If I throw something, or if I impart velocity less than root 2 0, what will happen?
Pendulum.
It will act as a oscillatory motion. So will it be SHM or oscillatory?
Oscillatory.
Oscillate.
Yeah, it is not SHM. SHM is a condition in which the
The
acceleration
force is
proportional.
perpendicular, proportional to x.
So this is not SHM, it is oscillatory motion anyway. Now, if I go beyond V, so how much we need to impart V to reach the maximum height, topmost point?
Root 4 GL. No, wait.
Root 5.
Root 5.
How?
Because we need tension to be non-zero.
Tension for balancing the.
We need
At the
velocity
topmost point, tension must be 0.
must not be 0.
Must not be 0, but equal to 0 we can take now for minimum value.
For solving question.
Yes.
So that is approximately 0, not 0. It is always on upper
Ha.
limit. It is more than 0.
Limiting to 0 positive.
So the condition for circle motion is the tension should not be 0 anyway. So T plus mg will provide you the centripetal force connected to mv square by r. So T is how much? mvc square by r minus mg.
Yes.
And this must be more than equal to 0. I mean more than and close to 0 for the minimum condition. Okay. In general, it is more than 0.
So VC must be root GL.
So
Now
VC
we can
square
put it in
is-
the equation.
So VC minimum we take as root 0. It is not equal. We take. It is slightly more than that. So for all numerical calculation, we take roughly as root GL. But this is the condition for circumvention. Understood? So the minimum is root GL. So if we need some kinetic energy here, so we have to impart more than potential, correct? So V turns out to how much? So it is not again V, it is V minimum we need this much. Is this clear? Hello, hello, hello.
Yes.
So the obvious question is, if we have a pendulum, and if I impart velocity, which is, let's take 4GL, you can clearly see, sorry, you can clearly see 4GL is more than 2GL, but less than 5GL.
Yes.
So it is not going to be oscillatory, right? So it will go in which quadrant? So if I take the traveling as the first, this is the first quadrant, this is the second quadrant. So it will first go in the second quadrant, right?
Yeah.
And in the second quadrant, at some angle, the tension will become 0, right?
Yes.
So we all know this question, right? So the way to solve is you have to take some reference angle. In many JEE question, they will ask you angle from the vertical itself, but I will take from horizontal from this position. Because I know it will happen beyond this angle, right?
Yeah.
So at somewhere the tension becomes 0. So first you apply the laws of motion till that point, and then you can probably put t equals to 0 to get the velocity of that equation. And it is very famous answer, right? So what is the laws of motion in general at this point? So how to write the laws of motion? So we can add net force to a center equals to mv square by r. Tangential equation is not required, but if you want, you can also write ft equals to m. But that is not required. But what is the f this equation? The one will lead to what?
T plus mg sin theta is equal to
So when you put t equals to 0, because you know that this should be 0 somewhere, because I haven't given the sufficient velocity. So we know that this will happen. So this is something which you should know. And then this will give the very famous answer GL sin theta, right? Okay. You have to be careful. Sometimes they give the angle from here, or they take from here, I mean, while solving. So you be careful how you write. So the answer is GL sin theta, which is very famous. Like now we know that at some V is as a function of angle. So once you got this relation of V at this position, next step is Write the conservation of mechanical energy between A and P. Conservation of mechanical energy between A and P. How to write? Tell me.
Sure,
MGL
we
1
can
plus sin
write
theta
half
is equal to MV square by 1.
Pardon?
MGL 1 plus
MGL
sin
1 plus sin theta.
theta is equal to half MV square.
कुछ भी.
Sorry, हाँ.
हम
तो
v
zero
half
नहीं हो रहा.
mv p square.
Hmm.
हाँ करेंगे v.
Did you say? No. So MGL plus half M, and this is very interesting. It is always GL sin theta. So with practice, you will remember that this is the famous answer. You can just write it without solving. M 2 2 2 GL GL GL. So 2 plus 2 sin theta plus sin theta equals to 1. Equals to 4. My bad. So 3 sin theta equals to 2. So sin theta equals to. In fact, this is so famous that you will come across 1,000 times in physics. So sin theta is 2/3 is the famous answer. And again, these are something which you should know. I mean, very famous. Don't take it otherwise. That you will use everywhere, but you should know how to solve. So at this particular angle, we know the tension will become loose or zero, the string will slack, and the subsequent motion is going to be projectile motion, right? So your subsequent motion is what? Projectile motion, correct?
Yes.
And we know the angle of projection is 90 minus theta, correct? So how much it will go up further? What is H max? V square cos square theta by 2g.
Yes.
Now you know that V square is GL sin theta. Cos square theta by 2g. So it is L by 2 sin theta plus, sorry, into cos square theta. So what is the maximum height of the journey from the bottom most point? So Y max is how much?
MGL 1 plus sin theta plus this value, right?
So Y max is how much? L1 plus sin theta plus
Plus this height.
L1 plus 2/3. 2/3. 1 minus 4/9. Okay. That is 5L by 3 plus how much? 5L by 27. So Y max is very famous answer 50 by 27L, which is slightly less than 2L, right? 27 into 2 is 54. It is slightly less. Almost you will reach the almost vertical, but not vertical. Hello guys, tell me, is this clear?
Yes.
Yes.
So it is 1.85, less than 2. Almost. So this is the approach. Whenever you know, so you should know this fact, okay, that if V is less than this, this will happen. And the similar question you can also go for the cylindrical or circular track problem. Track means, you know what the track is. Yes. So a cylindrical track is attached to. Attached to what? Tell me. Attached to a semicircular, to a horizontal part seamlessly. So there is no jerk if you transit. And the entire track is a fixed track. So it is not going to move. A block is given velocity V naught. Radius is R. So how much you must impart velocity to leave from the topmost point? How much you must impart? Tell me. What is the minimum velocity we need to reach the topmost point? Tell me, guys.
Root 5 here.
So the minimum is required is again 5 GR, correct?
Yeah.
And if you give 5 GR, then it will leave with what is speed?
Root GR.
Root here.
So what is
In
the
this case,
range?
normal can't be 0, right?
Yeah, so it is normal 0 only, na? Close to 0.
Close to 0, but I'm
Yeah.
telling.
Again, yes. So it will leave at the topmost point. It is when it is root GR. So what is the range?
It is simple parabola.
So range equals to
Root
range.
GR into so into 4R by G ka under root.
Which is 2R.
Yes.
So exactly, oh, so this is range. So the range is exactly equal to diameter, right?
Yes.
Again, very famous answer. If you want to know this answer, that if you give the minimum, it will come back to the same. Okay. Now, how to make the same question difficult or challenging? So the same question, if I give you in the chapter of center of mass. So what I'll do, I'll do something. So now we have a track kept on a frictionless surface. And the mass of the track is, you want to make it complex, capital N. And a block of mass is small m is given, and there is no friction anywhere. So the block and the track is having 0 friction. Find U minimum to reach the top of the track. I mean, I want to reach here, so how much, what I mean.
So the radius is R, right?
Sorry, this is done. My bad. Solve this question. I'm coming in fine. Okay, tell me if you've got some idea.
Sir,
Yeah.
sir, in that COM frame wala thing, that U is for a particular direction, or we talk about the net velocity?
The U is net velocity, right? In the CM frame, we always write the U relative.
Yes.
So right now, what is U relative?
Then initially it is U. Initially it's U. U, sir.
So U relative is U only. So what is the energy of the system in the CM frame?
Half mu U squared. M by M plus.
Okay, fine. Now to for the having minimum velocity, when the block will reach the top, the track will have some velocity.
Yes.
So at the topmost point, let's say velocity of the track is V. And because I want minimum, it means this must be the velocity of block must be 0 at this point.
0.
Because I want minimum, so I will make it 0. So what really matters is the V relative.
Sir, but will it be possible? Won't it have to have some like root here and the velocity? Otherwise, it
No,
won't be able to reach the top. No?
See, this is the V, no, which is root GR.
Hmm.
Always remember, in the circular motion, we always do the relative to the track relation. It is not ground frame. So we need root GR in the frame of track, not in the frame of ground.
Okay, yeah.
So my answer is done. I know this V must be root GR, right?
Yeah.
So in the frame of track, the block must have root GR. So I will assume the block having 0 velocity, track having velocity root GR, and my job is done. Then I can write because I can write the conservation of linear momentum, right? So from conservation of linear momentum, what you can write? Mu equals to capital M into root GR. That's it. Understood?
Yeah.
See, for reaching the top, the V relative must be root GR.
Yes.
So if I take the velocity of the block as 0 and track to be moving with the root GR, my job is done, isn't it?
Yes, sir.
And then we know from because momentum must be conserved, no? Because net momentum is towards the right. Okay.
Yes.
So we just need to solve the conservation of linear momentum because momentum is conserved, no? So finally, the track will have momentum, but the block will have no momentum. Block will have zero momentum, right? Because in the ground frame, block is at rest. Hello, hello.
Yes.
So I got the answer. Is this clear?
Yes, sir.
Okay. This is a one-line question. If you understand the concept, it's one line, but otherwise it's very difficult. So what is the learning from here? What is the takeaway? The takeaway is circular motion is solved in the frame of in, or you can say in that frame in which the motion looks circular. In the ground frame, the motion is not circular, right?
Yeah.
Because the block is actually moving like this. Do you realize this? Because as the block is trying to go up, the track is going right. So is the motion circular in the ground frame? The motion is not circular in the
No.
ground frame, isn't it? How many of you realize the fact that motion is not circular in the ground frame? You all realize?
Yes.
Yes.
Hasika, you realize?
Yes.
So we have to go in a frame where the motion is circular. Then we write the laws of motion or circular motion. Is this clear?
Yes, sir.
This is very important concept in this chapter. Very, very important. So circular motion we always combine with conservation of momentum. So now we are done. So how much time the block will take to reach bottom? Time taken by the block to reach bottom from the top will be?
So 2 under root h by g.
What is H here? I don't know what it is.
2r, 2r.
Yeah, so say that. So under root 2r, which is 4r by g.
Yes.
Because it is simply free form motion. Right?
Yes.
And in the same time, you will be moving horizontally with GR. Correct? So root GR is the velocity in the frame of track.
Yes.
Yes.
So we know that in the frame of track, it is GR. So in the frame of track, you will exactly land where?
The 2 r.
So we have done this question, right? So in the frame of track, it will move 2r. Okay.
Yes, sir.
Okay. Fine. So V minimum, okay, we got the V U minimum, which is M by M under root GR. That's one question. So let's see a similar question. So every question will have two categories. So we have a semi-circular cylindrical wedge. You can call it wedge. Semi-circular cylindrical or spherical, doesn't matter, wedge. I always start with the assumption that the wedge is fixed. Radius is R. And a tiny block, ignore the dimension, will be set to you, is given a gentle push. Because if I don't give gentle push, it will not start sliding, right? So if you slide slightly right, it will start slipping down, correct? as it will come down, its speed will increase or decrease? Tell me. As it will come down, what will happen to the speed? Will it increase or decrease? Come on,
Increase.
increase. So as it will increase, the normal will decrease or increase?
Decrease.
So can you find the normal as a function of theta?
Yes, sir.
Do it. Did you guys understand the previous problem? Tell me yes or no. The
Yes, sir.
previous problem
Yes,
is clear
sir.
to all of you. How to
Yes, sir.
think of a relative. See, circular motion is done on a track. So when the track is fixed, you are actually lucky that the motion on the track and motion in the ground frame will be similar. And you can apply the ideas of circular motion. The moment the path itself becomes, when the circular track starts moving, we can only solve in the frame of track.
Sir, we have to find normal in terms of just theta.
Just theta.
Okay.
Cos inverse 2/3.
Yeah. So again, because its angle is from vertical, if you think cos inverse. But I didn't ask you cos inverse to
Sir,
I
but
asked,
that is the angle where normal will be
yeah,
zero.
correct. So I asked normal. So normal is how much?
Sir, just a second, I got it.
That's the right answer. That was the next question. So okay, just was knowing that this is the future question I will answer. So when normal is zero, then the motion after that will be.
Parabolic.
Projectile.
So can you find the
Range.
final distance of the object when it will hit the
Yes.
ground from the center? What is x? Tell
Sir,
me.
it should be 3 mg cos theta minus 2 mg
Yes, n is 3 mg. 3 mg
cos
cos theta.
theta. Yes, sir.
Like this.
Yes, sir.
No,
Actually,
this one.
first
It
I
should be
wrote.
other way around.
Acha,
So what is the
Yes.
okay, what is the circular motion equation? What is
mg
the
cos theta
dynamics?
minus n is mv square by r.
And what is v square?
That we can get by conservation of energy. That is
2gr 1 minus cos theta.
2gr 1 minus cos theta. Yes.
So mg cos theta minus n equals to 2mg minus
2mg
2mg cos theta, correct? Yes, that's correct answer. 3mg cos theta minus 2. And if
Minus
you put
2.
0, you get cos theta equals to 2/3.
2/3.
And then from there onwards, the motion will be. So from it is like from the given height h. What is the height here? The height is r cos theta. Correct.
Yes, sir.
And the angle we will make with horizontal is also theta, right?
Yes.
And v is under root gr cos theta. Correct. This is what you got, isn't it? No, not gr. It's a gr 1 minus cos theta. 2gr. What am I? 2gr 1 minus cos theta, right?
2gr/3.
No, 1 minus cos theta. Yeah, 2gr/3. That's correct.
But
And this is theta. So you will move like this. Let's go x dash. So it's a rigorous calculation. You have to do first find the time of flight. And yeah. And then find the range. So you have to do this rigorous calculation. You know how to do this. Hopefully.
yes, sir.
So sine theta is how much? Root 5/9. Correct?
Yes, sir. Sir, by 3, no?
By. So then you try to find the time of flight first. So v sine theta into t plus half gt square equals to r cos theta.
Cos theta.
And then you know this should not be solved. Anyway, so you can solve it in advance. But this is not the question. The question is, when the track is fixed, you are happy, you know that how to solve. So the moment I take the same question in the chapter of center of mass, it becomes a challenging problem. So same question. M. To make it easy, I'll keep M both. Okay. I know. Otherwise, it will become very cumbersome to write and all. And now I give a gentle push to the block. So as you give gentle push, what will happen? The normal will act on the wedge also, right? And the normal will have component towards left and down. Depending
Yes,
on-
sir.
So if the block is sliding right, the normal on the block is up like this, but normal on the wedge is like this. No? So wedge will move left. And
Yes.
because the system is not experiencing any horizontal force, all forces are vertical. So in which direction momentum is going to be conserved? In which direction momentum will be conserved?
X direction, sir,
X
horizontal.
direction. Correct. So how we proceed? So at any instant time t, when the block has come down with reference to the wedge by angle theta, the block may have some velocity v. I don't know how much is this. I will let's call vx. Okay, let's call vx. So similarly, let's call vx equals to v. That looks nice. But the block will have two velocity. One, one because of the wedge itself, and other I will assume relative to the wedge like this. Okay, this is what I'm going to assume. So what is the velocity of the? So I'll assume. VR. VR is the relative velocity with respect to wedge. I'm assuming this. So with respect to wedge, it is going that way, as you can see.
Yes, sir.
And the wedge itself is going towards left with velocity v. So the net velocity of the block will be v left and VR tangential, correct?
Yes.
Yes.
Okay. So the first step is conservation of linear momentum. What we can write? The horizontal momentum must be zero, no?
Yes.
So tell me what should I write?
So VR cos theta should be V. Sorry, M into VR cos theta should be
M into VR
capital
cos
M.
theta.
Should be minus V also. Should be capital M or sir,
Yeah.
the masses are same.
Yeah, that's why I taken master. So it is the VR turns out with 2V by cos theta, right?
Yes.
So this is the first step. So what is the second step? Conservation of energy or mechanical energy. You have the relation of energy. So if you conserve the energy, what will get? Conservation of mechanical energy. How to write? Loss in potential equals to gaining kinetic of the system, not individual, right? System. So how
Yes.
much potential has been lost? Wedge is not going down. Wedge center mass is fixed. Block is coming down.
MGR
MG.
1 minus cos theta.
This is loss of potential. That will give kinetic to everything.
Yes.
So half is small m v square for the wedge plus block will have something complex. So it will have half
half M under
v
V.
minus VR cos theta whole square plus VR sin theta whole square. So want to write this way, simple way.
Yes.
And we know that v minus VR cos theta is v itself. And we have done this calculation. Mentally, we know this is nonsense. And VR sin theta. So okay. So we can write as MGR1 minus cos theta equals to 1 m v square. This you have to be smart and to solve this fast. So this is v square. Right? This is basically v only. From here.
Yes.
Okay. And then the other part is VR sin theta, which is 2v tan theta. Correct? So now see, it's a now simple question. This is simple, this is not simple. And then what we can write? 2v is for common, so 1 plus 2 tan is for theta. So v square turns out to be GR1 minus cos theta upon and if v square is this much, so what is VR? So you know that.
2V by cos 2.
So you can solve this way, but anyway, non-solve this much. So what they're asking in the tough question is like, find the angle at which it will leave the wedge. Now, what is the condition for leaving the wedge?
Sir,
Yes.
will this energy conservation be simplified in the CM frame if you do it there?
See, CM frame is helpful when we know that at some point there is no relative velocity. When there is always a relative velocity, it is difficult. I mean, of course, we can do.
Okay.
So in the CM frame, the initial kinetic energy is 0.
Yeah.
In the CM frame, the V relative is VR only.
Yeah, only we are.
Because center mass will move with V only, right?
Yes.
And now we have to check. What is the velocity of center mass? At what instant? Center mass is at rest in the horizontal, right? So in horizontal direction, the CM will have velocity not V always. It is not V. It is 0. Center mass will not have but center mass will have the vertical motion. Center mass is going down.
It will be down.
So center mass is always coming in this direction, and from the same point, it is always like this. CM is moving this way, always on the red line, no matter what. So center mass is accelerating downward actually.
Yeah.
So if you want to solve CM frame, it will be difficult, isn't it?
Sir,
Yeah.
sir, won't the center of mass shifting? Acha, हाँ, but there is no net force in the right direction.
Center of mass cannot shift right left. Center of mass will exactly fall down. The
Yes,
wedge
yes.
will go left and the block will go right, so that center of mass remains in the same line.
Sir, if we use the constraint relation that along the common normal velocity should be equal, then we
We
would
have-
get the
we
same
have-
as that VR is 2V by cos theta. No?
Yeah, we have done this already. This constant is giving this meaning. So VR we have taken with respect to wedge, not ground.
Wedge. Yes.
So in the ground frame, this is the two velocity. Correct?
Yes.
In the wedge frame, this is only VR.
हाँ.
Are you getting it? What I'm saying?
हाँ, sir.
So to write the circular motion, there is no difficulty because to write the circular motion, we have to know the velocity in the wedge frame only. No? So if you want to write the circular motion equation, kinematics, dynamics, what you write? mg cos theta. mg cos theta. Okay. And then we have to also find the it will come okay Olympiad level question there. And then at that instant it will also have some acceleration a, correct? And therefore it will also explain the pseudo force on the right, ma, right? So what is the net force towards center? mg cos theta minus ma center minus n is mv square by r. And if you put n equals to 0, okay, this if you make n equals to 0, that instant a will be also 0. So at the time of leaving, this term will become both 0. Do you realize this? The moment you leave the wedge, the normal is 0, which means the wedge will not accelerate. Hello, tell me.
Yes, sir.
Yes, sir.
And therefore, both term will be vanished. So you will get only question mg cos theta equals to mv square by r, which will give you vr equals to gr cos theta, correct? Hello.
Yes, sir.
Yes.
So we have the question 1, we have the question 2, and you can compare. So gr cos theta under root equals to 2 by cos theta, gr 1 minus cos theta, 1 plus 2 tan square theta. And definitely I am not going to tell you to square and solve, but this is a trigonometrical equation. Right? This is called trigonometric equation. So they may create a question and give you some value to let you solve. Maybe they will tell you, okay, do this, and then solve. Okay. So somewhere they have to introduce some simplicity in order to get the answer. But this is where not at all easy question. So if you square both sides, will come cos u theta equals to 4 1 minus cos theta upon 2 times. Let me do this. I mean, maybe. So cos cube theta plus 2 sin square by cos square. So 2 sin square theta cos theta. 4. So this is cubic equation, right? So sin square connect is 1 minus cos square. 1 minus cos square. Cos cube minus 2 cos 2 minus cos 2, right? Plus 2 cos theta equals to 4 minus 4 cos theta. Am I missing something? Everything's fine. This formula. So cos cube theta minus 6 cos theta minus 4 equal to 0. X cube minus 6x minus 4 equal to 0. Good. So they'll ask you this question. You know what they're asking? Find the value of x cubed plus 6x. And now this will become integer type question. Nice. So something like this they can create. So this is now this is a much more difficult. So a very simple problem of circular motion can be converted into very complex problem like this. Do you realize this? What we did today? So how many concepts we have to apply? Okay. Then we can go next. Any doubt in the previous problem? Tell me.
No,
In
sir.
the previous, any doubt?
No, sir.
Okay. Okay, am I audible? Yes.
Yes, sir.
Okay, it's a smooth track. There is no bump also. So what I'm doing is I'm dropping some object from a height h0, okay, which is not given. So my block is here. Okay. And the track radiuses are, and it leaves the track. The block leaves the track at 3r/2. So from center it is r/2, I think, right? Then only you can leave at r/2. So at this point, it leaves the track and then it follows the projectile path. You may be wondering, so how the color will change while it is going down? Because it may start with blue and because of some reason. So now it leaves the track and follow this path. Okay. Questions clear? Questions clear? Yes or no?
Yes, sir.
Sir,
Yes.
Yes. Yes, tell me. This
it's
question is
clear.
clear, no? So find h0. That's it. Find h0. And another question is find y max. I mean the maximum height to go y max. Do this question.
Seven by four or
How much? 11 by
7 by 4.
7 by 4. Like this.
Ha.
Hmm. Yeah, I think it's correct. So it's 7 by 4. Yes. Oh, yeah.
We just meet the normal zero at that point.
No, that's not possible.
No? Okay. Wait, we'll try.
No, just sorry. This is the right answer. Correct.
Because what I did now, I made normal zero at that point and then
Yeah,
back
so
to
that is the H naught, right? H naught.
H naught. 7
Yeah.
by 4 are is H.
H naught. Yeah, correct. Then what is the H max from ground?
Just a second. You told to find H naught, right?
H naught and Y max.
Okay, just a second. We'll do. That will also be 7/4 hour, right?
Right? HMS, this one.
But by using.
How
Okay,
it
no,
is
no,
same?
no. My bad. Sorry. Just a second. Fifteen hour by 8.
15 or better. 15.
Yes, I got the same.
No. This is not
15 hour by 8.
No, 15 or by 2 is not the answer.
It is.
No. Just let me confirm.
Okay.
But I don't think so. No, this is not 15 or right. It is
Sir, I'm getting 31 hour by 16.
Sorry, once.
30 is 27 by 16 hour.
Sir, 7 hour by 4 is itself 28 by 16 hour.
Okay, how much you're getting?
Sir, I'm getting 31 by 16 hour.
Just 31 by 16.
Yes, sir.
So what is the V coming? What is the velocity?
Sir, I'm getting 12 plus root 3 r by 8.
Sir, I did not specifically calculate V.
The root of GR by 2.
Velocity is root of GR by 2.
Yes.
Then V square sine square 60 upon 2G.
Plus 3R by 2. That
Plus 3R by 2. So we are getting same answer 15R by 8.
Yeah, let me confirm. So first of all, this is the angle, right?
30 degrees.
And angle is how much? 30 degree.
Yes.
So when you throw this velocity like this is 60 degree.
Yes.
And what is the V, by the way?
Yes,
The
I'm
root of
getting
GR
28, 27R by 16.
This one, no?
Yes, sir.
That's it. So what is the maximum from that point? V square sine square 60, right?
Yes.
Upon 2G
2G.
plus 3R. Is the
Yes.
answer, right? And what is V square, by the way?
GR by 2.
V is conserve the energy, no? So you
Sir,
know H
GR
naught.
cos 60.
GR cos 60. So,
GR by 2.
yeah, GR cos 60 sin, yeah, cos 60, that's right. Sin 30 or cos 60. So sin square 60 by 2G plus 3 over 2. I don't know where you made mistake, but this was not supposed to be done that way. So
3 by
3 by
4.
4. 3R by
Array, sir, I didn't take 1, 2. I got 3R by 8 plus 3R by 2.
somewhere you made mistake.
2G12.
So 3R plus this is 24, right?
Yes, 27 by 60.
So I think this is the right answer. Very
That 1 2 was missing. That 2G2 we didn't multiply.
ऐसे मिस करते रहना और क्या. Okay, so now how to make this question very difficult, like challenging problem. What we can do? So the same question, if I bring to the rotational dynamics, it becomes really challenging. So I'll show you one question in which the circular motion, when it comes to rotational dynamics with pure rolling motion, it becomes really interesting, very interesting. Okay. So we'll see how to make it very interesting. So let's go and let's see. Circular motion in rotational dynamics. Circular motion, rotational dynamics. Things we have to be careful of. Okay. So, okay, I'll take the same question. Maybe. Okay, we have done this, but so we have a fixed circular track. Okay. Of radius capital R. and we have a spherical object, a ball, of radius small r. It is a ball. So I will always assume solid ball, which means solid sphere. Friction is sufficient everywhere for the pure rolling. So the motion is pure rolling. So no need to worry about how much friction is there. It is doing the pure rolling motion. And the initial height of the center of mass of the ball with respect to the base is, let's call, how much? 3r is fine. Okay. And the small r, if I make it r by 8, so that things are really bad. So now the small r is 3r by 8. Find the maximum height reached by the ball. Maximum height reached by the ball. Is it okay? Questions clear? Maximum height. So the idea is simple. Again, the same thing will happen. You know what will happen? The ball will leave the track somewhere and will move like this. So I'm looking for this height, the maximum by the center mass. I mean, maximum height attained by the CM of the. So okay, before you solve, I'll explain what are the key. You want to solve first?
Yes, sir. 2 minutes.
No. You take at least 6 minutes. Don't take 2 minutes. 2 is
Okay,
too
sir.
short. Take enough time, think about it, and yeah. So what is the radius of track in which center mass is moving?
7 R/8.
7/2.
R plus 1.
R minus R.
Hey, R minus
R
1.
minus
R minus R.
Minus 1.
R minus R. Sorry.
Hmm.
But that is 7/8, right?
Yeah. So the answer I think is your track under observation is not R or small r. It is R minus R. So always solve question in R minus R frame. Because we only look for the center mass for the dynamics. Remember, dynamics is written for center mass, not for the body. Okay.
See, so the answers would be the same, just we need to replace capital R by R minus R and H naught by 3R minus R, right?
Pardon?
Like how we used to do previous questions.
Yeah. So you have to first check whether you have to check whether the velocity is the velocity 5 GR 5 GR minus R. Basically, it's under root 5 GR minus R. If it is not, it means you know what I mean. If it is not there, it will never reach the topmost point, correct?
Yes.
So you should also check whether it is under root 2 GR minus R. If it is not, it will oscillate. So there is no question of maximum. It will just oscillate. So you can just find. Okay. So the idea is we have to do some checkpoints, and I have given the value which is really bad. I mean, you never let to go to the top. I think. Can we go to the top? Or you can check. What is the condition for going to the top? No, it can go. Just a minute. This is 3R, no? This is no. This is too much. This will go actually.
Yeah, sir. It will go.
Yeah, I need to make it less than some value called. I have to make it 2R only. So okay, do one simple question. If we have a track of radius R and if we have a particle, what is the H required to go to the top? H minimum for top. Any guess? Or you can solve this question. You get a very informative answer, which you should
Sir,
remember
it
actually.
won't go, no.
No. You have to find H max to reach here.
No, I was talking about the first sum itself. In that, like, we can say that it's a solid sphere. So K square by R square should be 2
by
by 5.
Yeah.
So translational would be 5/7 of the total kinetic energy.
Correct.
So 5/7 into mg into 3R minus R by 8. Because
Yeah, correct. Very good. That's correct.
that would be half mv square. So I'm getting
Correct.
V as 105/56 GR. So that's
So
less than 2.
let's keep it R minus R term. So that's easy for you to write.
Extend. Why do you just take the translation? For which case, sorry?
Because it's the center mass
To
velocity depends
check.
on translation. The omega,
check
the
that.
half, see the half I omega square energy is of no use for dynamics, right?
Okay.
Isn't it?
Yeah.
Okay, so what I'm doing is I'm going to give no. See. Just it is pure rolling, no? So if it is doing a pure rolling everywhere, then okay, fine. Both energy will decrease. As V will decrease, omega will also decrease. Okay, you got the answer for this part, first of all. I'll come back to this question in there. What is the H minimum required to H minimum? to reach top.
5
And this is
GR.
a particle.
Sorry.
Pardon?
5 by 2 R.
Yeah, it is 2.5. That's the informative answer which you should remember. So if it is when the height is 2.5 times R, it happens. Okay. In this question, what we can do is we can take the inclined part rough and the track as smooth. Okay. And then things will change.
Sir, in the first case, R was with respect to center of mass.
Pardon?
In that sum on the right, which we have to find H minimum, that R is from the center of mass to the center, right?
This is for particle. So particle means
Acha,
dimension.
particle. Okay.
Yeah. So okay, I have to make some question actually here. Wait, I'll take some good question. So that you can practice both concepts at once. Circular will go with everything. No such questions. You should get at least once. So I have got one question, but that seems to be very challenging.
What is it?
Okay, let me give you a question.
So first, should we do the one that you gave earlier? Or?
Pardon? Okay, I'll do this question also. So here, okay, of course, see, to solve question of dynamics, let's say if you go from this point to this point. Okay. If I make it R as a fraction of this radius, it is a complex question actually. But if I make it very, very small than capital R, then the energy part you can add easily. I mean, the radius will be close to the radius of the track, but it is will do the purely. Okay. So that difficult question will not come. So I'll make it question JEE level. Just a minute. I'll make it one right up. Or what we can do is in the previous problem, I can make a small change. Assume R to be very, very small than capital. But it is doing a purely. That is for sure. Now the center mass is so close to the track that we can take the center mass moving along the surface of the track, right?
Yes, so capital R.
Capital R. So now things will not be that much complex. Now you can do the way you have been doing things before. But this will have the effect. The rolling will have effect. You know what? It will have effect on the energy part, right? In the velocity part.
The fraction
So now VCM will get affected, and therefore, when you are writing the dynamics, you should write mv square by r as centripetal force. Okay, so try this out. Now you can try it. It's not that difficult. So definitely it will not really, reach the topmost point, right? It will not reach the topmost point, but it will roll to a point somewhere and will leave the track, right?
Yes.
but this will not have the velocity v, which you can get directly by the energy of. You have to only take which energy? Translation
Translation.
energy. To get the to write the equation. Okay. So try doing this, and it will be easy for you. And then radius you can take as almost high. But this is also not required. No, I have solved many questions, but I know J has not gone to that level because it becomes too difficult to solve, I mean, numerically. Very cumbersome. Yeah. So pure rolling means you have to be careful about the energy relation. Rest you can do. So I'll just send you one challenging problem, which requires too much calculation. Just in case. Okay, I'm coming in 2 minutes. Solve it.
Uh,
Tell me.
I got the answer, but it's, I
Okay.
guess it's wrong. So like first I did half mv square is 5/7 into 2 mgr.
Hey, if you move by theta, so what is the loss in potential?
Mgr 1 plus cos theta.
Loss in
Sin theta,
potential.
sorry. Sin theta. Sorry.
It is 2r minus r 1 plus n into mg. This is loss in potential.
So it is mgr 1
If
plus
I
theta.
shut, if I shut from here, right, topmost point, and now if I'm
Okay.
here, so between these 2 points, the difference is only this much, right?
Yes.
So if this is the loss in potential, the gaining kinetic energy is, of course, there are two energy, half mv square and half I omega square.
Yes.
But because we know it is going to be 5/7 part is going to be translational.
Half mv square.
Yes.
So this is how we have to write the v square part. That's it.
Yes.
And then
But there is friction involved, right?
it is static friction. So there is no loss of energy.
No loss of energy.
Yeah. So energy can be conserved.
So basically,
in
the
presence of
condition
friction.
we need to find is for pure rolling, right?
Yeah, it is only for pure rolling. We are doing for pure rolling only.
Sir.
Yeah.
But the loss in potential energy will compensate for gain in kinetic of both parts, no, not just translational.
That's why I have put the fraction. No? The
Achha,
fraction of this will.
But half I omega square will also be there, right? So
No,
it
no,
will
no.
that 2
I
by
have
7
taken.
part.
I have taken the fraction. No?
Okay.
Understood.
To get this part only. So what you are saying is correct only. So out of the 7 part, 5 part will contribute for the translational, and 2 part will contribute for the rotational. And because I do not need that part, so I'm removing by writing this way. Okay. So those who don't
Yes.
remember, when you write the formula, this is the rotational, this is the translational fractional contribution. So 2/7 is rotational contribution and 5/7 is translational contribution. I hope you remember this part. And then you know the answer. This is always V square is how much? G R sin theta.
Sin theta.
So I can directly substitute here, right?
Yes.
I
Sir.
can, of course I can. So my answer is 5/7. And how much is this? R 1 minus sin theta
Yes.
is
Sir, also G will come. LHS part.
and G I'm cancelling from both sides.
Okay.
Mg I'm cancelling actually.
R sin
So
theta
sin
by
theta by
2.
2. Sin theta by 2, right?
Sir, R also will get cancelled.
R will get cancelled actually. So I can rearrange, no? 10 1 minus sin theta is 7 sin theta is 17. 10 by 17. Correct?
Yes.
Alright.
Sir. Yes.
And you can clearly see this is not 2/3, the old answer. Okay. Hello.
Yes, sir.
So the question difficulty will change as we change the chapter, as we bring some new concept. So once you, that's why I always say, once you understand the basic is the laws of motion only. Everything else is modification of the basic. So we have to make some small changes to get to the new concept. So in the next lecture, I will take some question of CM frame, and I'll give some challenge problem as well. So I think center mass is very easy. I'll mostly take the variable mass problem. Okay. So from center mass, the JEE can ask a difficult question from the variable mass. So that will take care. And we'll see rotation we have been seeing actually throughout. So we'll see some unique example of rotational dynamics. At least we'll solve 5 to 6 questions of dynamics. And that completes the mechanics part. Okay. After that, I think you should only focus on the revision. Don't try to learn something more difficult as of now, because you can do it after the JEE-Mains again. So go back to your revision mode. Try to capture as much as possible. I hope that your mechanics and its concepts are now more enlightened than before. With this enlightenment, you can actually crack the other theory. Okay. So
Yes.
also make sure that you remember all the formula of magnetism and electrostatics. Okay. EM waves. So if you have written those formulas, start revising from today itself. Try to keep on flipping through the pages of your previous chapters and study accordingly. Okay. So today is what? So I'll try to keep a lecture again on. Okay, if JEE-Mains is not there, then I'll have lecture. Otherwise, after JEE-Mains. All right.
Yes.
So anything else from mechanics you want to learn as of now? See, moment of inertia you have to practice only. I'm not going to teach. So that I have discussed already. You can go and watch, or if you want to see the notes, just check the notes. So try to master the moment of inertia.
Sir,
Yes.
impulse momentum and angular impulse momentum. Can you do that?
Yeah, that is not easy. There's nothing like derivation. It's a one-line thing.
Yeah, not derivation, like problem equation. Like
Yeah, you need to practice through problems. So I'll give you problem. I will solve problem, in fact, because giving will also not help. So that's good. Okay, at least we can take this concept in the next lecture. Okay, fine. That will be done. Anything else? Like something unique which I also feel is difficult and I should put some time. For anything layman, I think you should revise from notes, try to solve. Because even after JEE-Mains, I will be taking only questions. Okay.
Yes, sir.
And through question only, we'll try to see the theory. Like what you should know, what you can probably make mistake. So that is a better learning. I think going through the chapter and so going through the theory again will not help. Only through problem you can see the difficulty of theory. Okay. Or the application of theory. All right. So hope to see you in the. I don't know what is going to be your date of examination. If there is no date, then definitely I'll keep one lecture next week, Thursday.
Okay.
Otherwise, you know what you like. Otherwise, after the JEE-Mains. And now, please keep on solving PYQs again. Go back to your PYQs mode. Now, this time, don't solve each and every question. Solve odd problems or even problems. Just solve randomly problem. At least 40 to 50% of every chapter should solve, just to get the hang of the theory again. So that the thing should be fresh in your mind. That's the whole idea. All right.
Yes.
So again, start from the 12th part. I think 11th part. See, if you understand mechanics once, you can do it again. But 12th part, or the part which is less less revised or studied, which is the 12th question, the last topics. You have to revise rigorously to be able to solve the question. So that won't be difficult, but that will be. And I think there are few lectures, right? For magnetism, I have put 1 or 2 lectures. EM wave, I have put only 1 lecture, right? So if you want, you may revise from the lecture itself or the way you want. Bye and take care.
Bye, sir. Thank you.